Okay, so for our prompt today, I just want you to look at these four graphs right here, A, B, C, and D. And I want you to go ahead and describe, if you can, describe the relationship of each quadratic function to its x-axis. Notice that I'm using the term quadratic function. Do not call it a quadratic equation, call it a quadratic function, because we're actually having a graph now, a graph pertaining to a function. And quadratic simply in this case means, what did you look up here? It has what shape to it? A U. A U shape, and more specifically, we want to describe this as a parabola. Have you ever heard of that term before? Okay, so instead of saying it's a U-shaped graph, you call it a parabola. Or you want to use an adjective for that, it's called a parabolic curve. Right?
It's even harder.
Okay, so parabola, or simply just say it's a quadratic function. Then we would know that it has to do with the curve graph function. And I want you to go ahead and look at these four graphs right here and see if you can find any relationship between the graph itself to its x-axis. Notice that I'm pointing out to the x-axis specifically. Yes, James?
They're both on all of them are on 1, 1.
All of them on 1, 1, are you sure? Would be 1, 1.
Like the point.
The point. All of them on 1, 1. What do you mean by that?
Like the x and y, the points.
1, 1 is right here. You're saying, here's 1, 1. Here's 1, 1. Here's 1, 1. Here's 1, 1. I don't see any connection. Okay? So look carefully. Okay, what is it? Anything that you have in mind, just go and share it out.
They're either above, like.
Okay, wait, say it again.
Like they're above, or they're like bottom. I don't know how to explain it though.
So look at A. What do you say?
Like it's above the zero. Like
it's above the zero. So wait. Good, you're getting somewhere. If the graph is above 0, how is it relating to the x-axis? What do you
not using it.
Huh?
It's like not using it.
It's not using it more. So more or less, you would say it's not crossing over.
Yeah.
Ah. So you're saying for graph A, it's not crossing over the x-axis at all because it's above it and it's facing where? Upward. Okay. What about graph B? It's facing downward. Okay. And what else do you see for graph B? That pertains to the x-axis. It crosses over the x-axis. How many times?
Twice.
Twice. Okay. So we're getting somewhere. Go to graph C. Same thing. In what way? It's going up and?
It's below.
Ah. Okay, notice how you said that. It's interesting. That for it to be crossing over, in this case it's crossing over, it's facing upward, it has to stay below that for you to do it, right? Unlike this one right here, it's facing upward, but it's not crossing over because what's happening?
Oh, it's above.
It's above the x-axis, so there's no way it's going to cross over. Look over here. It's facing downward, but it's not crossing over the x-axis because it's below that level. So how could you cross it over? It's facing downward, it's below that already, right? So, very good observation right there. But I want you to see something here, though. Notice that right here it's crossing over the x-axis twice. Here, it crosses over 0 time, or none, right? And this is also none. No roots at all. Ooh, interesting. I just brought up something. Roots. Okay. Now, I want you to be able to come up here and show me. So you've seen all the variations, either upward facing or downward facing for the graph. And that's basically what the quadratic function should look like. It's a U-shaped graph, parabolic curve, upward facing or downward facing. There's no side way, okay? So don't try to do that. We don't have that function yet. You'll learn it in Algebra 2. But for here, it's either upward facing or downward facing. I want you, or anyone here in this class, to come up here and show me, please, a graph that will crosses over the x-axis exactly 1 time. Can you think of that situation? Here, I gave you an example of a graph where it's crossing over 0 time, 2 times, but I want you to come up here and show me a graph where it crosses over the x-axis exactly 1 time and has the same curve, though. Has to have the same curve. Has to be a parabola, right? It has to cross over the x-axis exactly one time. Can anyone in this class come up and kind of make a sketch of that graph for me? To show me that it crosses over the x-axis.
Can the top
Has to
touches
cross
it?
over or
Just the top?
Huh?
it has to cross over or just touch it?
Touches it, yeah. Touches it one time. Well, crossing over means touching, right? So it touches one time. Can you show me that case?
Wait, how about
Can you
Huh?
see
this
the
one
top?
touches it?
Like that.
Like the little curve on the top touches the line?
Doesn't matter. Just come up and show me one, yes.
I'll try it.
Yeah, sure, go ahead.
I'll try it.
It has to be upward facing or downward facing, not sideways.
Where are you recording?
Okay?
That's what I was thinking too. My voice is
One the other way.
Okay, so let's see if he can show us.
No, don't do it in black. Black's boring.
Red is fine. Okay, yeah. Good job. Nice. Very good. Good job. Very good. And he's right. Notice that it crosses over the x-axis exactly one time. Touches it one time, right? Instead of facing upward, can we just also show it like this as well? Face it, touching it over one time, right? So upward facing or downward facing, we have it crosses over exactly one time. So far, we have 3 different ways to graph this. Let me show you all the variations here. We have a graph where we have exactly 0 x-intercepts, not crossing over the x-axis at all. It's either like this or like this. Is that correct? Right above it or right below it. Can't cross it. We have a situation where
It's a basketball.
we have a situation where it crosses over the x-axis exactly twice, like that. See it? 1, 2. Or downward facing, it's crossing over as exactly 2 points as well, right? When we, of course, we have a third situation where it crosses over exactly 1 point. I just showed that to you, where it just hits that x-axis one time, right there. Or you can have it like this too, exactly one time. So, recall what we learned yesterday. When we solve for solutions, what's the maximum number of solutions that we can have when we solved yesterday?
2.
2. What's the minimum?
1. 0.
0. And then the in-between is exactly 1. We learned about discriminant yesterday too, is that true? The discriminant is like a warning signal that tells us how many solution we should be aware of ahead of time. And over here, all of a sudden today, I just showed you how many ways your graph can cross over the x-axis. 2 time, 1 time, or 0 time. Any aha moment where you say, oh wait, there is a connection about what we covered yesterday versus today? What do you think about what we covered yesterday that has to do with today? The quadratic formula, in this case, yesterday we solved to get x equals to something. And over here I show you the x-intercept. So can you connect what we covered yesterday to what we covered today? Yes?
When you get 2 answers, that's the 2 points connected to the x.
That's what? What's the
X-intercept.
x-intercept? So essentially, all that we're doing so far, when we started with yesterday solving for x, we are solving for the x-intercepts of the graph. Okay? That's what we've been solving for. So I just showed you like 3 ways to solve the x-intercept. We can start with factoring, zero product property. We can also do the completing the square approach, or the third approach that I just showed you was quadratic formula, right? And for this particular function, the quadratic function, we don't call them x-intercept. Instead, we have a very nice name for it. We call them the roots. So if I ask you to find the roots, it's exactly the same thing as the x-intercept. So I want you to learn to recognize the keyword, the term here. If I ask you to find the roots, I am really asking you to find the x-intercept of your graph. Where is your graph crossing over the x-axis? The roots. And we have 3 ways to solve for that. Okay, any questions so far? All right, so now let me just show you the very basic of the graph itself. All right, here's our sentence for today. Of course, it's more to completing the square. Okay, so we learned completing the square, and there is something to it that I want to show you today. But before we go back to the sentence, I want to go ahead and ask you to go ahead and graph this for me. And I want you to show you all the components to the graph. First off, let me show you that. Let's say I have a graph that looks like this. It's a parabolic curve, so we call this a quadratic function. Okay. Okay. So I want to show you a couple of things about the graph. Maybe I should do it all at the same time so you know what I'm talking about. All right, guys. Let me just make it a bit smaller here. Grip that. Okay. So one graph facing like that, and the other graph facing this way too, so you know what I'm talking about. There it is. Okay. So they're both quadratic function. One is facing upward, one is facing downward. That's all. But look at this. We know for a fact that when we look at the quadratic function here, we have exactly two intercepts. We call them roots, right? And you know by now that roots can either have 2, 1, or none. In this case, for the purpose of showing, I do have 2 roots to show you. So these are called the roots. Another thing that I wanted to point out is this point right here and this point right here. This point right here happens to be at the lowest point of your graph. Is that true?
Yeah.
If you look at your graph, it is at the lowest point. It is at the bottom of the graph. That point right there is called the vertex. And because it's the lowest, we call that the minimum point, vertex. And over here, that highest point is also known as the vertex. But instead of calling it the vertex, we call it, to be more specific, what we use to describe that? Maximum point. Question so far? So you need to know your terminology, that's all. I mean, in terms of telling you, oh, if I ask you to find a vertex, you know where to locate your vertex. It's either a highest point or the lowest point, maximum or minimum point of your graph. And the characteristic that you see is this. If your graph is upward facing, you will always have the lowest or the highest point. High. Upward facing.
Lowest.
See, if you just put up yourself, you see it. The lowest point, right? And if it's upside down, downward facing, you have the highest point of the vertex. It will be the highest. Okay. Another thing though, if I'm going to draw a line right through your vertex, cuts it in half, right? So basically, isn't the left-hand side a reflection of the right-hand side?
Yeah.
We call that line right there the axis of symmetry. Okay? Right there. That's the axis of symmetry, where it cuts the graph in half and it crosses over your vertex exactly. Okay? And of course, if you fold it onto each other, it will fold perfectly. Okay? And that's how it is. So, questions so far? Another thing is this, and I want you to be aware of. We know that our quadratic equation has this format. ax squared plus bx plus c equals 0. We learned this format yesterday, right? That's an equation. Now, if I'm going to turn this back into a function, it will now look like this. Nothing has changed except for the 0. I just replace it with a y because we want to be able to graph it. So just like how we have the linear function y equals mx plus b. Now we have a quadratic function, so we're going to have it equals to y equals to something. And y equal to ax squared plus bx plus c is our standard format for a quadratic function.
So that's the new formula?
It's a standard function. It's like y equal mx plus b kind of deal. Here it's y equal to ax squared plus bx plus c. It's a quadratic, and for you, how do you recognize it to be quadratic? Look at it. Look at the highest power. What power is that? It's a square. So every time you see a square power, you know that it's going to have this shape.
Okay.
That's how you know. And if you don't see a square, you just see the bx and that, it's just a straight line. Okay? And that's how you tell them apart. Any questions so far? Here's another trick, though, that I want to share with you today. You see that a in front of your x squared? That a? If that a is bigger than 0, your graph will always be facing upward, meaning a positive number. If you start with an x squared as positive x squared, your graph will always be facing upward. If your a, which is the coefficient in front of the x squared, is a negative value, meaning less than 0, you will always see your graph facing downward. Always. Question so far? We're good? Okay. Now, yesterday, we learned how to solve for the roots. Now we know that they are the roots, right? Using the 3 approach. Today, I'm going to teach you how to find that vertex right there because guess what? For a line, we need 2 points to make a line, right? For the parabola, how many points do we need? 3. Minimum of 3 points. And you need to have the vertex, because the vertex is like the seed of your plant. Either it's going to grow upward or it's going to be grown downward. You need to know where it starts from, right? So you need to find a vertex, and the vertex is found. It has a formula for it too. It's actually pretty simple. Let me show you how to find a vertex. So vertex right here is actually a point. Is that true? And a point, in this case, let me show you to find each individual component of this point. To find the x component of the point, all you have to do is take out UB, take the opposite of that, divided by 2 times A. And we talked about pulling out A, B's, and C yesterday. So you shouldn't have any problem pulling out your A, B's, and C. And that's the basic formula for that, to find the vertex. Okay? So this will give you the x component of it. Okay? And then how do you find the y component? Well, this is the first step. After getting your x, take that x and substitute it into the function to solve for y. And there's the function right here. You just have to, whatever you found for x, take it, substitute it right back, and solve for y. And once you have your y, you have the complete point. That will give you your vertex. See that? Okay, so let me just go in and do an example with you right now, just to share out what's happening. And it makes perfect sense when you see it. Okay, all right, tell me when you're ready. Good? We're good to go? Okay. All right, so let me just go ahead and erase some of the problems that I have up here so we can get started. Okay, so let's start with this. Go back to the problem that we started yesterday, the prompt. On the prompt yesterday, I gave you this. 0 equal to x squared minus 2x minus 15, right? Remember that problem that we did yesterday? I show you 3 ways to solve for this problem.
Yeah.
First way, I factor. I solve for 0, use the zero product property. Second way, I complete the square. And the third way, I use a quadratic formula, and we prove that they have the same exact answers. Now we know that after we got this, yesterday we got 5 and x equals to -3, right?
Yeah.
After we got those, we now know that these are called the roots. And roots are nothing more than just x-intercept. If you were to graph this thing right now, the only thing that you see is this. Here's 1, here's 2. That's it. You have no idea where your anchor point is or your vertex is. You have no idea whether it's going to be right here or up here. But I just give you a very big hint. You see this right here? What is A? 1. Is it positive or negative? Positive. Positive meaning upward facing or downward facing? Upward. So that means your point, your vertex has to be up here, down here, or up here.
Down.
Think about it. If it's upward facing, where do you think your point should be? Bottom. So at least you have a clue that your point that you're trying to find has to be down here somewhere. See, that makes sense, right? And now you just have to go back and use the formula I just gave you. First of all, find out x. The point, the vertex is x and y, so let's go ahead and find out what x is. X is negative b over 2a, right? Let's pull out the b. What's the b here? Negative 2. What's the a? 1. You know where I got the a, b from, right? Which one? Oh, that's a y.
Wait, A is the x squared, right?
A, B, C, in that order. It has to be in order. That's why I asked you, I always urge you to make sure that your equation's in order, right? So now, if I solve for this, this is what I got. Negative of a negative 2 over 2 times 1, right? And so the answer is just 1. See it? So this is step 1. I found my x. Second step. I take that 1 right there that I just found, and where do I put it back? Into x. Right? And And you say, wait, if I'm solving for y, I don't see any y, but don't forget, this 0 right here can be replaced with y, right? So we can just turn it into a function. So there it is. So now it's y equals to 1 squared minus 2 times 1 minus 15. And I solve this completely. I would have 1 minus 2 minus 15, which is negative 16. So I got my x, I got my y. How do I form a point?
X and Y.
Which is
1
negative 16. See, we predicted that based on the information given that your graph is going to have a vertex that's down here underneath the x-axis. And we just proved that it is 1, negative 16. So if I'm going to go ahead and find it, 1's right here. So let's assume negative 16 is way down here. So your point is going to be right here. You see it? 1, negative 16. And that's your vertex. And by the way, is that a maximum point or a minimum point vertex?
Minimum.
Okay, now I just have to connect these and connect them to make a graph. You also realize that if you don't want to graph it this way, you can do a table for it, the XY table. You can pick your own points. It takes a while.
Yeah.
The 4-column style table, you can certainly do that, but hey, if you know how to do this, it's shorter. So, there's the graph. Oh, by the way, where's the axis of symmetry? How do you graph that now?
1.
Where's it crossing over?
1.
Right here. Just have it right through your vertex, and that is called the axis of symmetry. And if I ever ask you to give me the equation of the axis of symmetry, it's right here. You got it in your first step already. X equals to 1. When you set up to solve for your vertex, the first step, you are also finding the axis of symmetry as well. Okay? And that's the information that I have for you. Questions so far on how to graph? We're good? Okay. One more thing that I want to share, and I think it's important enough. We now know that our vertex is at 1, negative 16, right? We got our 2 roots. Watch what happened. Let's say that you're lazy, you don't want to find a vertex. Instead, you want to just do this. And I want to show you here. Put this aside, pretend that we don't have the graph yet. We don't know that the roots are 5 and negative 3. So you're just going through the usual approach, and this time you happen to pick completing the square. So that I'm going to go and show you the step thoroughly. Watch. To complete the square, I would move the 15 over, right? Negative 15 over, right? Because I don't need it. If I move the 15 over, I would have 15 on this side, and I have x squared minus 2x on this side. Agree? What is my new square going to be? Or the missing square? What's the area of that? What's the area of the missing square? 1, right? Because you have negative 2 here cut in half, and then you have that square. So is it true that your new square is going to be 1, and of course, if I'm going to be doing it to one side, I have to do it to the other side as well. We're good? Question on that? Okay. All right, so I'm just going to make room basically. Okay, all right. This becomes 16, and this here on this side will be factored to what? X minus 1 squared. Do you know how I got that? For those of you who don't remember, you can still do this. 1 and 2, and you get negative 1, negative 1, right? That's fine, if you want to do it that way. But for those of you who know this negative 1 is actually the side of your missing square. It's always going to be like that. Okay. At this step right here, if you were to branch it and do it into 2 steps, watch what happens. If I'm going to solve for the roots, that means I'm going to go ahead and take the square root both sides. So I have plus minus square root of 16. Square root of 16 right here equals to square root of x minus 1 squared. Is that true? And you solve it the same way. You got x minus 1 equals to plus minus 4. And we found out that the answer is 5 and negative 3. So that's what we did. But watch here. This is where the magic happens. On this side, I label this the function side. It's like one stone killing two birds kind of deal for this kind of problem. Because on the function side, instead of trying to solve it now, after I factor it and write it in the square terms like this, I move back a 16 over. Then it looks like this. Is that correct? And then because this is a function, I now replace the y, 0 with y, because I want to change back into a function. And now your problem looks like this. And you say, yeah, so what's so interesting about that? I want you to take a look very carefully with the two values that I have here and with the vertex that I have there. Are they almost the same?
Yeah.
Except this value right here inside the parentheses is the opposite of what you see. Other than that, everything looks exactly the same. So what I'm trying to say is, if you complete the square, you can also put in this format to pull out your vertex as well without having to go through x equals to negative b over 2a and solve for it. Look at that. The only thing that you have to be aware of is this has to be the opposite of what you see inside the parentheses. This is negative 1. Outside it's going to be a 1. The negative 16 outside parentheses stays the same outside. But you are getting the same exact vertex when you complete the square as well. Hey, if you want to do it that way, sure you can. The reason I have to teach you this way is because sometimes when I give you a problem like this and ask you to quickly identify the graph, you can pull out the vertex right away without having to go back and solve for everything, which can take a long time. Okay, am I making sense so far in terms of trying to figure it out? Okay, with that in mind, let's move on to our actual example here. What? I know I give you all the steps here, asking you to find the vertex, axis symmetry, but we know that we can actually do everything in one step. So let's take a look. What do you want to find? Let's find the vertex. Let's do it. Let's find the vertex. How do we find the vertex? You want to use the formula to find the vertex, or you want to complete the square? Okay, let's use the formula then. X equals 2, negative b over 2a. Okay, let's start with that. What is our b?
1. Wait, no. 2.
2. So it's going to be negative 2, right? What is our a?
1.
1. A is 1. Interesting. Wait, by the way, if a is 1, our graph is facing upward or downward? Oh, so at least when you do this, start with that so you know that your graph is facing upward. Okay? And then here we get negative 1, right? Now that we have our x here, this x equals to negative 1, also our axis of symmetry equation. So we answer 3a. Moving on to the actual vertex. How do we find y?
Well, X back into
Plug it back in. So y now equals to negative 1 squared plus 2 times negative 1 plus 18. You see, I'm just basically plugging that negative 1 back inside the function and solve for it. And if I solve, I got 1 minus 2 plus 18, which becomes,
17.
what is it?
17.
17. So I have my x and my y, those 2 points combined to be negative 1 and 17, right? This is your vertex. And is that vertex your maximum point or your minimum point?
minimum.
Very good, because you know it's facing upward. So let's take a look. Your minimum point is right here, negative 1, and 17 is like way up here. Oh, wait a minute, interesting. If your point is up here and you know it's facing upward, that means your graph will look like that, right? You just kind of sketch it, right? Will we have any roots if it's facing like that?
No.
No, then in that case, we don't have to solve for the roots at all because we know we have no roots. See how useful that is? It's facing upward, it's not crossing over the x-axis. If you know it's facing downward, then you do have to solve for the roots, either by using the quadratic formula, complete the square, or try to factor. But in this case, we know we have no roots. We stop right there and we're done. This is just a basic sketch of our graph. Does this make sense? Okay. Now let's see if you can actually identify this one. Tell me, which graph belongs to that equation or function? By the way, since this function is already written in this format, let's move the 1 over, because we want to complete the y by itself, right? So we move the 1 over. Y now equals to x plus 1 squared minus 1. Look at this format. Can we pull out the vertex? What is the vertex?
Negative one, negative one.
-1, -1. Oh, wow. And by the way, is this graph facing upward or downward? Upward. So upward. So which, oh, if it's upward facing, which two can we eliminate?
B and D.
B and D are gone. And we know that the vertex is at
Negative
-1,
one.
-1, right there. It's upward facing. See how easy that is? And if you want to be sure and you want to test it out to make sure it works, test any point. Let's say, oh yeah, what if I test when x equals to 1, what is y going to be? Look, when x equals to 1, 1 plus 1 is 2, 2 squared is 4, 4 minus 1 is 3. So at 1, y should be 3, and it is right there. So that's a good way to test your graph as well. But at least we just learned a trick that because this is positive in front, it's upward facing, so we can eliminate all others graphs that do not belong there. Any question on that? See, this whole lesson is I'm trying to teach you to recognize graph, be able to recognize the function itself. Like this one right here. Look at this graph. It's upward facing. By the way, if you look right here, everything's upward facing, so you cannot eliminate anything yet. But look at your vertex. What is the vertex of this graph?
1, negative 1.
1, negative
Wait,
2.
yeah, 1, negative 2.
1, negative 2. 1, negative 2. Go back to each individual function here and tell me which function can you actually pull out of 1, negative 2?
J.
1, negative 2? You pull out as is in here? Think about that.
8.
8. Oh, -2, 8.
No.
Which one?
8.
Why?
Because if you move the 2
Let's move it back. If you move the 2 over, don't you have y equals to x minus 1 squared minus 2? At least this minus 2 match, right? Right? And the only thing that you need to remember now is the inside here has to be the opposite when you take it outside. So if it's the opposite outside, it has to be a
It's out.
1. So in that case, is that correct?
Yes.
It is.
Oh, no.
Right?
Oh my God.
See, the inside here, when you pull it out to make a point, has to be the opposite of what you see. And that's what's happening. But the outside of parentheses, they can stay the same. We're good, right? Okay. Check this one out and tell me. Which graph belongs to what you see up there? Which two can you eliminate?
A and C.
Why?
Because it's moving on screen.
Very good. And because notice that your A here is a negative value, that's why. So you're right. You can certainly eliminate A and C. You're down to just B or D. Now you have to determine where the vertex is. Since this is not written in the completed square format, you have to pull out your B and your A to do it. What's your B in this case?
1.
1.
0.
Wait.
0. You see this is missing a term?
Oh, yeah.
Remember I told you that if anything is missing, you have to write it out. In this case, look, y equals to negative 1/2 x squared plus 0x plus 1. Is everything in order? And there, nothing's missing. Well, in this case, if it's missing, you got to fill it in. And clearly you see A, B, C. See it? So B is 0. A is negative 1/2. According to our formula, x equals to negative b over 2a. If b is 0, that means the top going to be a 0. 0 divided by whatever value here will give you a
0.
0. So if x is 0 and you plug it back in here, what is y going to be?
B.
If x is 0, you plug it here. This will become 0, right? 0 plus 1 is 1. So isn't our y 1? So in this case, the vertex is 0, 1. Look here. Which one has 0, 1?
B.
There it is. Do you see how easy it is to identify your graph? You can always find the vertex that way, right? X equal to negative b over 2a. Okay? All right. All right, that's it. Here's the recommended problems for today. And that's it. And I'm going to have your DMQ up